Hello all. Hello all. Let me resize my screen. Yeah. Welcome to AK App Logics. Today we are going to discuss about the um, unsized. How to declare the unsized number or the value to the variable. Okay. In the previous class we have discussed about the sizing number. How to declare the sizing number. Right. This is the previous class. And in previous class we have seen some examples related to the sizing number. So today in this class we're gonna see how to declare the unsized numbers. So numbers without base format specifications are decimal numbers by default. Means if you're gonna see the first example over here, integer a equal to 5423. Okay, here integer is the data type, is the variable name, and the value is 54323 is a decimal by default. By default it will be treated as decimal. Why? Because we haven't mentioned any uh, size and base format, right? We haven't mentioned, right? We haven't mentioned any base format, so that see, base format is not mentioned. And gets a gets means this particular a variable a gets a decimal value of 5423. Okay, I hope you got this. And if you're gonna see this second example, number without a size specification have a default number of bits depending upon the type of simulator and mission. Okay, in the first case, number without a base format. Here there is no base format, and as well as size also there is not given any size. Okay, we just represented the number, so this particular number will be treated as by default with decimal number. Okay, if in the case of they have given the base format and the tick mark, but they haven't given the size, it means it will be taken the default size. Okay, depending upon the number of bits, it will be taking on the default size. If you're gonna see this particular second example, integer a, and the value is tick h1a d7. Okay, h is the hexadecimal base for this particular number is in the form of hexadecimal, and the number is 1AD7. Okay, so for one single digit we require 4 bits, so it means there are in total 4 hexadecimal digits which require 4 into 4 16, right? So the size will be 16. Okay, the size this particular a require 16 number of bits. But the thing is, depending upon the simulator and mission, the size varies, and also depending upon the data type that we have given. Here we have given the data type is integer, so integer default size is 32 bits. Okay, integer default value is 32 bits. Size is not specified, right? Because a is integer is 32 bits default size, but actual bits required to store this particular value is 16 bits, right? Why? Because 4 into 4 16. Okay, so the value will be stored like this in 32 bit form. Here actual we required 4, 4 into 4, that is 62, 16 bits, but we have used the data type as integer, right, which has the default value of 32 bit. So the number a will be stored in the 32 bit, um, followed by the number, and remaining will be stored with 0. Okay, let us see the example. With this example we can able to understand how we gonna take this. Let me comment this particular thing. Okay, comment. Yeah, let me comment and write an example for you. I'm passing the video to write the example because it will kill the time. Okay, yeah, if you gonna this is the code, this is the module, and we have to end the module. So I have entered the module, and the module name is unsized because we have learning about the unsized, right? So we have declared the two variables, one is a and one is b, and we have stored this particular examples 5423 and th1a d7. Okay, and we have used the initial begin block which will be executed only one time, and we have used the dollar display which is the uh, system task which is used to print the values, like in printf in C. Okay, yeah, and I have used percentage 0d for the this particular number a. Why? Because in this particular statement we have told that defaultly the number will be decimal. So if the default value of the this particular a is decimal, then we should get the resultant as 5423. So that so to knowing to to knowing whether the default value is decimal or any other, so I have given the percentage 0d. Okay, so if we get the 5423 in the result, then we can able to say that the this particular a equal to 5423, where 5423 is a decimal number. Okay, so and also I have given b is equal to percentage 0h. Okay, which is an hexadecimal number. Why I have given percentage 0h means because in the number we have assigned tick h1a 1a d7. Okay, let me run this particular code. To run this particular code we have two commands. Those are these particular commands: I verilog -o verilog underscore class dot vvp verilog underscore class dot v. Okay, I'm running this particular code. There are no any errors, so that we didn't display any errors. So we have to run the vvp file. Okay, I'm running the vvp file. We can able to see that we get the a equal to 5423. Okay, I have used the percentage 0d, and in the first integer a equal 5423, this particular thing, we haven't mentioned any size and base format. Means by default what I have told, by default the number will be taken as decimal. So that I have used the percentage 0d in the display statement, so we get the answer value as 5423 only. It means we can able to say that the whenever if we didn't given any size and um, any base format, so we can able to say that particular number will be stored as a decimal number. Okay, in the second case, integer b equal to tick h1a d7, I have used percentage 0h as base format. Sorry, uh, format specifier as for format specifier I use the percentage 0h. So we got the value as 1a d7. So let me print this statement again, where I will use the format specifier as b. Why? Because the size of the size will be stored in the number of bits, right? So let us check how many number of bits that these particular variables integer a and b are stored. Okay, there are no any errors. If you gonna see this, we got 4 4 and 4. The first number took the 15 number of bits. Okay, the first number took the 15 number of bits. Okay, this particular number 5423 converted into the binary, we will get stored in the 15 number of bits. It means this particular a occupies 15 number of bits to store this particular value 5423, while the second number uh, is used to store 4 4 4. Okay, and 1. This is also took the 15 15 bits, but I have told it will take the sorry 13 bits. It took the 13 bits, and this is also took the 13 bits. Okay, this it took the 13 bits. 5423 means equal to how much? 1010 1001 0111. So to get to avoid confusion, let us use the underscore symbols. So we have to use from here underscore underscore. Let me erase this. Yeah, you can see that it occupies 13 bits. Okay, yeah. So this particular number, let us write how many number of bits it will take. Okay, 1010 and me 1101. Sorry. Yeah, 1010311. So if you're gonna see this, we got displayed the 13 bits. So this number, in the last MSB we have one, right? So these zeros are neglected. So this particular number 1A D7 is equal to this. Okay. Yeah, so you can see that A is stored in the 13 bits, and as well as B is stored in the 13 bits. Okay, let us see by removing this particular 0 in the format specifier whether we are getting the default size of 32 bits in the resultant or not. So let me check this. Okay, check. So I am removing the 0 in the format specifier and checking whether getting these particular values A and B to the default size of integer or not. Yeah, check. Yeah, see, if you're gonna see this, if you're gonna see this, for the first case, we have printed A and B values with respect to their format specifiers. Those are %0d and %0h. For the second case, what I have did is I have used the %0b and %0b for the A and B to get the actual uh, number of bits required to store both the particular numbers. For the second case, we got A will occupy the 13 number of bits and B will occupy the 13 number of bits, right? So for the third case, I have removed the 0 in front of uh, format specifier B in the display statement. So we get the answer as answer in 32 bits. For A and B, both the values A and B get stored in 32 bits. Why we get 32 bits here is we have used the data type as integer, right? We have used the data type integer default size is 32 bits, so we haven't mentioned any size in the assignment statement over here. So the variables occupies the whole integer default size. Okay, by not specifying the size of the variable, what is the disadvantage is it gets occupied to 32 bits. But the actual size required to store these particular numbers A and B are 13 bits. Okay, individually, right? So this is the disadvantage we have uh, while storing the number without specifying the size. Without specifying the size is getting occupied, right? So for this thing, you have to mention the size in base format properly to save your memory. Okay, yeah, I hope you got this example. You guys try it by your own, you will able to understand. Okay, this is the thing. Yeah, in the next class we can able to discuss about the negative numbers.